Hello, this is my walkthrough video for my AVL tree programming assignment 2. Firstly, I'm going to go through how a single zip code lookup is going to work in my program. This is my program in VS Code, but at the moment my debugger isn't really cooperating, so I'm going to have to open up Visual Studio. Just to use the debugger, but I did submit my my assignment using VS Code with the make file. Okay, let's see. So zip code lookup. This is me reading this is where the program reads the CSV file into the data structures, into the list, the map, and the AVL tree. And after that is done, later on in the program we get to the point where I generate my random zip codes to go search for to test the speed of the lookups for each of the AVL map and the STD map. So let's see. This is where the lookup happens for my AVL tree. So I'm going to run the program and we're going to take a look at what that looks like. It's going to take a couple seconds here to load everything up. Oh. Okay. I'm just going to start walking through. Alright, so what's happening right now is the Boolean function find data is going to go into this search function that is going to search through the loaded zip codes until the zip code is found, and this is going to take a long time if I continue to step into like this. So I think if I step over, or if I just continue, it'll eventually, well, maybe I can just Oh, looks like I found one. I found 623, so it found that zip code that I loaded up in the program. And I can just keep going, but that would take a really long time. Let's see. And I'm just going to start over and run the program without debugging, just to sort of show what the terminal looks like when it successfully goes all the way through. And then I have a nice little print at the end that shows the difference. Or the map search takes about double the time as the AVL tree search. Let's see. Let's go take a look at my insert function. So this is my public version, which uses my insert function, and we'll go take a look at my insert function right over here. So all this. And I'm just going to walk through this function with my debugger. Now we're passing in a node, a key, and a city that's been populated using this constructor right here with all of the different data from the CSV file line. And these are the parameters right here that we're using over here. And I'm just going to walk through this function. So the first node, I believe, is going to be null, so we're going to have to actually go through a few more lines. And then we're actually going to be able to see the full function after we get through this. Okay, here we go. Now we're constructing a new node to insert. And I have a little node counter at the end there too, and then this function is going to return the new node that's been created, or the new root rather of the tree. And then, yeah, there we go. There's a couple new nodes created. Oh yeah, and I forgot to mention how. Well, let's see. I think that after this next node is inserted, a rotation is going to happen, so let's do that. Okay, let's insert a new node. And I believe that since this third node is being created and the key is going to be, we started out at I think 607, and as we get further and further down the line of zip codes, the number is increasing, so I think this tree is going to be right heavy, so I think the I think it's going to require a left rotation for the RR case, so let's just watch that happen. Okay, we're checking the balance factor. And it looks like the balance factor is returning -1, which I don't think is actually going to require a rotation. Yeah, I guess not, so I'll just have to keep on going. Oh, here we go. Here's the left rotation happening now. We're checking if either of the children are null. And this function right here is just flipping around the nodes and rebalancing the AVL tree at runtime. And this is what allows it to be so much more efficient and fast for searching than the standard library map. And there we go, there's the left rotation.